So just so it's a little bit more easy for you to get familiar with the different type of forms we might see, we're going to give you a video of just power functions as the outer function. And so what do I mean by the outer function? So if we had to decompose this function here, so g of t in this example would just be the inner function, right? We're trying to compose it into f of g of t. And so g of t, our inner function here would be t squared plus t, and our outer function, f of t, would be equal to t to the 10th. And so when I say some power function examples, I'm saying this outer function is something like t to the 10th or t to the 9th, but it's not going to be like e to the t, or it's not going to be like 5 to the t either. It's going to be t to some power. All right. And so in these examples, so remember the chain rule tells us that first we want to take the derivative of our outer function. We do f prime of g of t, right? So we just take the derivative of this f of t. And so to do that, we're going to drop down our 10, and then this is t squared plus t, and then we decrease our 10 by 1, so to the 9th power. Now the chain rule says you're not done yet, right? The chain rule says you need to multiply by the derivative of your inner function, right? So I'm going to multiply by d over dt of t squared plus t. And so when I write it out like this, notice that this side of the equation, I'm done taking derivatives, right? So this part of my right-hand side, I'm done taking derivatives. But over here, I'm not done yet. I still need to take a derivative, right? And so to finish this one off, I'll write 10 times t squared plus t to the 9th. This stays the same, but over here I need to take a derivative of t squared plus t. Now what's the derivative of t squared plus t? I'm going to put it in these parentheses. So the derivative of t squared is 2t, and the derivative of t is 1. And since this is a sum of two functions that I know how to take the derivative of t squared plus t is just 2t plus 1. So this whole thing here, this whole line, would be my answer to the derivative of t squared plus t to the 10th, right? So the derivative of my outer function, where I leave the inner function the same, so this is that part, times the derivative of g of t, that part. Right? So let's try something similar here. So what's my inner function here? And so I've put a 9 out here to kind of throw you off a little bit, but remember, you can always just, if you have 9 times something, if you have a constant times something you know how to take the derivative of, like that, you can just move the 9 out front, right? So that's what I'm going to do. I'm going to move the 9 out front and say, well, it's going to be 9 times the derivative of this thing, right? So what's my inner function here? So my inner function is this ln of t plus 2, right? And so what does my chain rule say? It says take the derivative of the outer function. So it says take the derivative of this exponent thing. Now don't forget about your 9. So I'll have 9 times, and so I'm going to bring the 6 down. I'm going to leave my inner function the same at first, right? I leave the g of t there on its own, plus 2, and then I decrease my 6 to a 5. And the chain rule says, nope, you're not done yet. You need to multiply by it. You need to multiply by the derivative of your inner function, so the ln of t plus 2. And so again, in this part, I'm done taking derivatives. I've taken all the derivatives I need to, but here I have some work left to do, right? I need to take the derivative of ln of t plus 2. And just like before, it's going to work out pretty nicely if you remember your rules. So I'll have 9 times 6 ln of t plus 2 to the 5th power. So by my rules, this is going to be the derivative of ln of t plus 2. The derivative of ln of t is 1 over t. And what's the derivative of 2? Well, it's 0, right? And so if I simplify this thing, 9 times 6 is 54. I can't really simplify that much, right? So I have the ln of t plus 2 to the 5th power, and then this part out here is just times 1 over t. Okay? So we're writing a lot, right? We're writing a lot, but just remember the first thing you want to do is kind of take the derivative of that outer function. So like with this example, the outer function here was that 6th power. So I drop my 6 down, turn it into a 5. and then I multiply that result by the derivative of the inner function. Okay, so let's look at one more example here that may not look like a power function at first, but this actually is, because remember that I'm not going to take any derivatives yet, but I'm just going to rewrite this as I want to take d over dt of t to the 10th plus 7, and then remember the fourth root is really the 1/4 power. Right? And so once we write it like that, hopefully we can see that, well, my inner function here, g of t, is equal to t to the 10th plus 7. Right? So if I want to take the derivative of this, I take the derivative of my outer function first, so I drop down that 1/4 t to the 10th plus 7, I leave the inner function alone, and then I do 1/4 minus 1, it's negative 3 over 4th, but I'm not done yet. I need to multiply by the derivative of this inner function, right? So the derivative of the t to the 10th plus 7. And so just like before, the derivative of this function here is going to be equal to 10 t to the 9th plus 0, right? The derivative of 7 is 0, the derivative of t to the 10th is 10 t to the 9th, and this part all stays the same. 7 to negative 3 over 4. And there's a little bit of simplifying you can do here because of this plus 0. So this is really, this whole thing in parentheses is really just 10 t to the 9th. So you really get 10 over 4, which simplifies to 5 over 2 t to the 9th times t to the 10th plus 7, all to the power of negative 3/4. So again, we're writing a lot, but it always boils down to take that outer derivative first and then multiply it by the inner derivative.